welcome everyone. Today we are start a new topic which is kinematics. We are about to embark on a journey, not a journey through the space, but the journey through one of the most fundamental concepts in physics, which is kinematics. Today we are going to translate the beautiful chaotic motion of physical world around us into the precise and elegant language of physics. So here you see a cyclist is going straight way, but not we are not always go straight. If we want to go somewhere, we take path like this and then move like this and take like this kind of road, okay? As I show in orange map, okay? Now it all starts with simple but profound question, which is how do we accurately describe a journey? When you tell a friend about your commute, you might say it took me 20 minutes. But a physicist would say I traveled 6 kilometers east and an average speed and so on. We are looking for more precise way to capture the story of motion. Here I describe two two scenarios. In first scenario, man is running on this machine, but there is no displacement. Man is running for the 30 minutes, but there is no displacement because he is running on the same point. Now, in the second scenario, we have a one person which is going point A to point B, but this time it walks and he cover 10 meters. So every word like far or fast aren't precise enough to describe the universe. To truly understand motion, we need a new blueprint. What is it? Let's go. That precision, we have to follow a specific path. Think of it, it's like flight path of our understanding. First, we define some kind of words, kind of vocabulary of the motion, which is very crucial for the describe any motion. In that, we define distance, displacement, speed, velocity, and acceleration. Then we move towards relativity of motion. The question arises in mind that motion is relative or not. So we can check in this part. And then the third one, the most important, if we have to transform our physical motion into the graphs or mathematical world. So we use the graphs, okay, geometry of the motion, translating physical movement into the graphs. In that, we see position versus time graph and the velocity versus time graph. Before we can describe a journey, we need to understand the vocabulary. The most important concept to grasp is the great divide in physics, which is scalars and vectors. Now, we have already saw the difference in my Unit 1 video, okay? If you not watch the Unit 1 playlist, then go and check it out. Now, here I describe a brief description of the difference between scalars and vectors. In scalars, there is a magnitude only. There is no association with the direction. You have to just write here a number like 20 centimeter, not the direction. Okay. Now, in that scalar part, we have a distance, the speed, and on the other hand, the vectors, we have a magnitude as well as the direction. So it's like if you say the velocity of my bike is 20 kilometer per hour north, so that means you are going to the north by the 20 kilometer per hour speed velocity. In that, vectors, we have a displacement, velocity, and the acceleration. Here, the most important sentence is that in physics, the direction changes everything. That means, suppose you say that the your speed about 21 kilometer per hour, but in what direction? You didn't mention it. So the person is confused of your direction. It means it's north, south, east, or west, like that, or any kind of angle. Okay, so it should be you should be describe direction also when you deal with the vector quantities. If there is a no direction mentioned in vector quantities, it's meaningless. Here's that difference becomes clear. Let's look at the cyclist. Here, let's say it's a point A. Now, cyclist is going through 500-meter east, and then it's move backward and go for a 300-meter west. Now, let's understood. Here, I take as a point B. If there is a point A here, the cyclist go start this journey from this point and it go like 500 meter, and then it took back in the direction of opposite direction and it covered 300 meter. So now we have to find the distance covered by the cyclist as well as the displacement. Now for the distance, we have to calculate the whole journey of the this cyclist. Means 500 meter plus 300 meter, which is 800 meter. Regardless the direction, okay, you have to just add the quantities. You didn't bother about the direction. In If you talk about the displacement, there's a X backward direction and it cover 300 meters. So my answer is 200 meter. The another thing is that the displacement is A and B. Okay, the displacement is the depend only on the final and initial point. It didn't bother about the how the journey was. Okay, so if you want to find the displacement, check final point and the initial point. That's it. But for the case of the distance, you have to consider the whole journey. Okay, I hope your concept of distance and displacement is clear. Okay, let's take another example of the circle. Now, if person is at this point, okay, now it travel along this way and reaches the at point B. Now, in the case of distance, the person moves along the circumference, means half of the circumference, means the circumference is given by of any circle is 2 pi r, but it covers half of the circumference, means divided by 2, and it will give us pi into r, and the radius is given here, which is 5 meter. Now if you multiply by this and you will get the 60 meter. Okay, now this is all about distance. If you talk about displacement, then as I said earlier, We have to just uh, consider the final and initial point. So in this case, the final point is B and the initial point is A. So you have to just take the minimum distance between 2 points. So the minimum distance between these 2 points is about like this along the diameter of the circle. So it says if you calculate the displacement, it is a diameter, okay? Diameter which is given by twice into radius and which is given as a 10 meter. So here we got the distance is 16 meter and the displacement is 10 meter. So here is the difference, okay? Now, another thing is that in the displacement, you have to mention the direction because it is a vector. So if you didn't mention the direction, it is meaningless. Now, so what is the direction? So from this to this means downward direction. If person is like this circle and the person is here and then it goes to this point, that means the direction is upward. I hope you understand this circle concept or in the distance and the displacement. So the main line is the, or you can say a law, which is distance cares about the path, but displacement doesn't. Means displacement cares about only the start point and the finish point. We understand displacement and distance. Now we move forward and we have to find the average speed, average velocity. Okay, average speed, velocity. Now for the average, what does mean the average? We know the formula for speed, like distance moved along the actual path upon time taken, means like this speed is equal to distance covered by the object and taken time. Now for the average speed means v is equals to x2 minus x1 upon t2 minus t2. Now x2 means the final point and the x1 is the initial point when the object begin this journey. T2 is the final time when it reaches the final destination, and T1 is the time when the about the motion about the motion. Okay. Now, if you consider our cyclist example, it covers 800-meter distance, and trip took 120 seconds. Then, what is the average speed? If you consider initial position is 0 and the initial time was 0 second. After doing all the journey, it covered 800 meters, means x2 is equals to 800 meters, and it took time about 120 seconds. So now the average speed is given by like this 800 minus 0 upon 120 minus 0, which is given by 6.7 meter per second. Now, if you consider the average velocity of the cyclist, so you have to consider the displacement covered by the cyclist upon taken time, same is as the speed. Now the for the cyclist velocity, which is 200 meter, displacement is 200 meter east upon 120 second, and you will get the answer 1.7 meter per second in the east. Here I mentioned the direction. Here it didn't mention the direction because the speed is scalar quantity and velocity is the vector quantity. Okay. Whenever you deal with the velocity, when you deal with the vector quantity, always write the unit or direction, sorry. Now, here I mention a formula like this. Here, X shows the displacement, T shows the time. But here delta, which is a Greek symbol, it shows some change in. So in what? The change in displacement or position or change in time, okay, which is also given like this, the same meaning, okay. So don't be confused when I write delta here, okay. Delta is a Greek symbol of to uh, represent the difference in this quantity. Okay, now the bar, here I use bar above a V, means that the velocity is a vector quantity. Every uh, quantity which is a vector, you should do like this. Okay, always write like this. Otherwise, it will not represent the actual vector quantity. This is all about average speed and average velocity. Here, I show the scale of the motion from snails to starlight. Here, it is just for the information, our range of the speed. Okay, the snail is very, you can say it is very slow up to the light in the vacuum, which is very high speed. You can say 3 into 10 raised to 8 meter per second. Okay, this is all the range of the speed is our relative motion. So here I mentioned in the second part, this is our second part. So it is about a relative motion, which is very easy to understand the concept. So are you moving right now? It depends who is asking. Okay. Now, in my first scenario, we have a ferry which is going 8 meter per second in this direction. Okay. I mentioned here the direction as well. Now, the bird is also moving this in the same direction of the same speed. Now, consider the scenario. You are sitting in this ferry. Okay. Now, if you watch the bird, you may feel like bird is stationary with respect to you, but someone is on the earth's surface and see this bird, and he or she feel like it is going this direction with 8 meter per second. Okay, try to understand this concept. You are in this the ferry which is same speed in this going in the same direction as bird is going. So you feel like bird is stationary with respect to you, but someone who is standing on the earth's surface and see this bird, and it is like the bird is going 8 meter per second in this direction. Okay, so for you the bird is stationary, but the person who is standing from the earth is the bird, he is watching bird, so he says that the bird is not stationary, it is moving. Now the person who is standing on the surface, he also sees that your boat or your ferry is going, or you are also going with this speed and this direction. But you may feel like I am on the ferry is stationary, and you see that the person who is standing on the earth, he is going this direction with 8 meter per second. Okay. Now let's do some another example, which is of train. Okay. Suppose train is going this direction of the 25 meter per second with respect to ground, or you can say earth. Okay, now boy is going in the train, boy is going this direction while the train is moving this direction. So the speed of the boy is about 1 meter per second with respect to the train. Okay, the train, if you are standing on the outside on the surface of the earth, you see that the boy is not going about speed 1 meter per second. You may feel like the ball is going this about 24 meter per second in this direction, about you see that the boy is going about 24 meter per second in this direction. But if you are inside in the train, your answer will be changed. Now, if you are sitting on the train and boy is coming to you and you say the speed of the boy is 1 meter per second, I think you get my point. If you talk about the motion of any object, it is more important where you watching from, means frame of reference. If you change the frame of reference, the motion of the any body or any object will be changed. Okay, I hope you get this point, and which is very easy or understandable topic. Is our how we capture the motion in the geometry. Okay, I hope you understand and familiar with the coordinate geometry. In that case, we define some axis, x-axis and y-axis, and in that we are trying to describe any motion. Okay, here I mention the speed of the car, the position of the car. Sorry, at some time, car is here. After some time, the car is x6 and x7. After some time, the car is about this position. Now, create position versus time graph. So first we understand the position versus time graph. Here we have four cases. First case 0 to a, which is a straight line. So it means the constant velocity. Means the body covers the same distance in the same time of interval. Okay. The next one is A to B, flattening curve. Means slowing down speed. If the body has a 10 meter per second speed and then it comes to the 5 meter per second, it shows this kind of structure. At the point V, gradient 0, particle is momentary staged, means the position is fixed about the time, means the object is not going anywhere, so the object is stationary. Now, B to C, the downwards direction curve, negative gradient moving backward means in our example of cyclist, it move the backward U-turn. Okay, like this, it shows this kind of motion. Okay, this is the all the cases of position versus time graph. Now the concept of instantaneous velocity. Here, the whenever you ride a bike or drive a car, you may see the speedometer. It shows some kind of speed. It shows instantaneous speed, not the average speed. Okay, this is the same concept in the velocity also. Means the velocity at the particular time, like at 2 second, what is the velocity? At 4 second, what is the velocity? It's like this, not the average one. Now we move forward and go on for velocity versus time graph. Now, in the velocity versus time graph, it shows like this. And if you find the slope of the velocity versus time graph, you will get the acceleration. On the other hand, if you find the slope of the position versus time graph, you will get the velocity. Try to remember it because we are doing this same thing on our when we solve the problems. Okay. Now the area under this curve of the velocity versus time graph, it shows displacement. Okay. Now the two golden rules. The gradient means slope of the velocity time graph shows acceleration, and the area under the curve of v and t graph, it shows displacement. Now here I shows two graph. This is about the increasing in velocity. This is a point where the velocity is constant, means it goes the constant velocity. And then the velocity decreases, means velocity decreases, means first we have a 1 meter per second, then we go for a zero point 0.5 meter per second, like this. This is all about velocity versus time graph and the position versus time graph. We started with the raw, messy data of the physical world. We defined some key points: distance, displacement, velocity, and speed. Then we will interpret the data on different graphs. From the understood that what type of motion can be. We should we show the slope and the area under the curve are powerful tool to find hidden values. We actually use this in the examples and exercises. In my next video, we will understand acceleration in detail. We will see equations of motion under uniform acceleration. Thank you for watching. Subscribe for more physics lecture.